So this video is just going to be like a recap of everything fast. So we have 3 energy systems: glycolysis, or PCR glycolysis, oxidative phosphorylation. They all work simultaneously, not one is working by itself. PCR is your fast, short bursts of energy. Glycolysis is your longer duration in comparison to PCR, and then your oxidative phosphorylation is when you reach that steady state, and that includes the Krebs cycle and ETC. Then we go into exercise metabolism, where we can determine what fuels we are burning through RER, which is respiratory exchange ratio. If we're burning fats, we're going to be at a 0.7 RER, and if we're burning carbs, we're going to be at a 1 RER, or respiratory quotient, sorry, not RER. Anyways, but then we go into muscle contraction and how the nervous system plays a role in our contraction. So we have that axon, we have that neural impulse from our brain. It goes down the axon, it propagates, it depolarizes and then repolarizes, and it goes into the neuromuscular junction and the presynaptic cleft, where it binds to neurotransmitters, and those neurotransmitters go into the in plate potential, where they send signals to the sarcoplasmic or the sarcomere, and then it goes down the goes down the T-tubules, and then calcium's released from the sarcoplasmic reticulum, and then it binds to troponin. Troponin shifts trypomyosin, so actin and myosin can bind together. ADP and a phosphate group gets shuttled off, allowing our muscle to contract. And then we have like a half contraction with the ADP, and then the full contraction with the phosphate. Then after we have muscle contraction, we go into and we did cell signaling, and then the circulatory physiology is basically how our heart is pumping, so our cardiac output, and heart is pumping top down, bottom up. So you have the AV node, or the SA node, which is the pacemaker, so how fast your heart is going to pump, and then you have your AV node, which is like the slight delay, and that correlates to the EKG and the atrial repolarization and all that stuff. And then you go into the respiratory, and that's like your VO2 max and your Fick equation. Fick equation is your cardiac output times your AVO2 difference. Your cardiac output is regulated by your heart rate and stroke volume. Your stroke volume then goes into 3 subcategories of venous end diastolic volume, contractility, and then afterload. So your preload is going to be your venous contraction, your muscle pump, your respiratory pump, and basically how the blood comes back in to our lungs and stuff. And then the AVO2 difference is just, this is going to sound stupid, but the difference between the atrias, or the arterioles and all that stuff, and the veins. I'm going really fast because this video is really long. And then we can go into endurance training and resistance training, where we can tie everything together. And we have like overload, specificity, neural tuning, hypertrophy. Those are the 2 together. And yeah, so basically, moral of the story is that exercise physiology is basically pushing our endocrine system out of homeostasis, and then having mechanisms to keep us from dying, keep us from, or have ATP so we don't have a spare tank, and acid-base balance so we don't literally die. And yeah. Okay, I'm gonna stop this now.